This week we're taking a look at rationals and fractional exponents on integers. So I have broken this down into 3 steps to solve these types of problems. We are first going to try to change our radical into fractional exponents, which we've been working on for a couple weeks now. The second thing we're going to do is we're going to apply the exponent product rule, which means that we add the exponents on the like base. Sometimes to do this, you need to find a common denominator first if there isn't a common denominator already. And the third thing we need to do is simplify the exponent if possible. So sometimes you'll have to, sometimes you won't. So we have a few examples we're going to work through. What we want to do is put the radical exponents into the equivalent exponential form. And we want to try to simplify our exponent as much as possible. So number 1, we have the square root of 7 cubed times the square root of 7. So first thing I'm going to do is change my radicals into fractional exponents. So the square root of 7 cubed, remember we could write that as 7 to the power of 3 over 2. The 3 is coming from the exponent right there on the inside of the radical, and the 2 is coming from the fact that this is a square root. And then it's multiplied by 7 to the power of the exponent. So there's no exponent written on that 7, so we can assume that that's 1. So 1 over 2, because again, that's a square root. So that's step 1. Step 2 is we're going to apply the exponent product rule and add the exponents. So this is going to be equal to 7 to the power of 3 halves plus 1 half. And we can simplify that to 7 to the power of 4 halves. And then the third step is just simplifying our exponent as much as possible. So 4 halves, we can reduce that fraction. So that is 7 squared. And I know that you could rewrite that as 49. On Delta Math, it's going to be multiple choice this week, and they're going to have you just leave it in this form. So I know you can simplify that a little bit further, but just if you can't find your answer, if you were to go ahead and say 49, just look back on your work and you should find the step before that, your answer will be on Delta Math then. The second problem we have is the 5th root of 3 to the 4th times the 5th root of 3 to the 6th. So let's change these into fractional exponents first. So we have 3 to the power of 4 fifths times 3 to the power of 6 fifths. We have a common denominator, so we can go ahead and use our product rule and add these exponents. 3 to the power of 4 fifths plus 6 fifths. If we add those together, we get 3 to the power of 10 fifths. And step 3, we can simplify that exponent to 3 to the power of 2, which I know is equal to 9, but again, Delta Math wants it in this form. All right, so very easy for the first 2 problems. If you notice, these problems both had a square root and a 5th root. The roots were the same degree. Let's look at some problems where we have a different degree on our square root, on our roots. So number 3 here, we have the cube root of 2 times the 4th root of 2 to the 5th. So we have a cube root and a 4th root. So we can start with the same thing where we're going to change our radicals into fractional exponents. So that's 2 to the 1st. So this is going to be 2 to the power of 1/3 times 2 to the power of 5 over 4. And we can still add these together. So that's 2 to the power of 1/3 plus 5 over 4. But the problem now is that you can't just add these right away. So this is where I was saying you might need a common denominator. So my common denominator, I'm going to use 12. So if I write 1/3 as 12, that's going to be 4 over 12. And if I write 5/4 as 12, that is going to be 15 over 12. Now that these have a common denominator, I can go ahead and add them together. So 4 plus 15 is 19 over 12. Sorry, that's 2 to the power of 19 over 12. And that fraction does not simplify any farther, so that is going to be our answer to this problem. The last problem we're going to do right here is number 4. We have the 4th root of 5 cubed times the 6th root of 5. So let's go ahead and write these as a fractional exponent. So I have 5 to the power of 3 over 4 times 5, and that has a 1 for the exponent, to the power of 1 over 6. Let's add these together. This is 5 to the 3/4 plus 1/6. And again, I need a common denominator. So the smallest number I can get 4 and 6 to both go into is actually 12 for this one as well. So I'm going to try to get them each over 12. So if I write 3/4 with a denominator of 12, that is going to be 9 over 12. If I put 1/6 over 12, this is going to be 2 over 12. So I can add 9 plus 2 to get 5 to the power of 11 over 12. And 11 over 12 doesn't reduce, so that is what your answer is going to be.